raises the issue of code generation and code analysis projects on the shoestring. Code analysis is probably better, but we have problems with that. So we have a programming language that is awesome in any kind of compiler stuff, right? We have, like, I think, one of the most the libraries of any other parsers, right? We can parse Haskell, we can parse JavaScript. There are actually 2 JavaScript parsers that seem to have been recently maintained. There are Python parsers, there is CMake parsers. Who used CMake forever? Okay, 2 people, 4 people, awesome. So there are also parsers for very esoteric language that I cannot even pronounce, so I will spare you. And it is worth noticing that code generation and code analysis is growing in importance. So most programs now are generated by computers, basically, on every level. So we generate a lot of Haskell code from, for example, tools for automatic code generation. We also analyze Haskell code in many programs. So average CI pipeline uses GHC, uses probably something like HLint or Complexity to check the code quality, and many other tools, right? So this is just for Haskell, and then you have a code base that includes other languages. You will use SLint, you will use other tools like Splint for static code analysis. So I just looked at few code generators that are written in Haskell and looked at the techniques they use to generate the correct code, right? In particular, Amazon Kgen. If anybody used the cloud deployment from Haskell, that's the library that basically covers all AWS APIs, right? And the only way to do it is to use code generation from metadata that is already present in Boto, right? In Python binding. There is sysppHS that does similar thing for GNOME and GTK. There is a JSON autotype that tries to automatically infer types and parsers for JSON. And there is Stratosphere that is typical kind of small code generation project, or what I call code generation on a shoestring, which is, let's just build the types on top of CloudFormation scripts, right? CloudFormation scripts are those scripts that you can use to deploy to AWS and configure everything in a reproducible manner, right? So add types to make correct programs. There are also various refactoring tools that I will skip here in this case. So this is typical example. This is the Stratosphere. It's basically Haskell DSL for code generation. So you get some extra correctness from types, but they wonder why and wonder how you ensure that the Stratosphere itself is generating a correct code, at least syntactically correct. No, I'm not even saying type correct, right? There are experiments in the science community with staged programming, but that's not code generation in the shoestring. First, you have 2 or 3 years of writing custom parser and meta language and so on. So that I would discard from this type of projects. So the current approaches are like make a big parser that is for your custom application, like Haskell SRCX, right? The second thing is if you really want to go cheap, you just do a string concatenation, right? And the example of string concatenation is here from a JSON autotype. We really have very, very little variance here. So we just generate instances and type declarations. And we just concatenate string. No guarantees here, right? That's what we want to avoid, because basically debugging this is hard. You can work with this approach only if you don't really have a lot of code generation code. The next thing, a little bit more convenient, is what Stratosphere uses, which is basically string interpolation. So you don't do anything with that would basically type check it, but at least you use interpolation, and then if you want a little bit more clever approach, you put it into a template and then put it into separate file that can be opened in, say, cloud formation mode to syntax check it, basically. Amazon Kajen uses similar approach. It puts the templates in a separate file. They are called ED templates, so that you can open it. And it's actually the best practice for code generation projects that you make sure that you can at least have a syntax checks for the templates that works the same way as the source language would. And then the problems that you have. So no validation until the compilation, so you need to have a big test base. I recommend using QuickCheck for that and going through all language syntax if you have a way to generate it. But that's not necessarily on a shoestring budget, right? Because the Haskell syntax, if you try to generate all valid Haskell programs, that would be a while, right, to implement it. Next, you just discard all the white space sensitivity usually, right? So you use the template in one place that indents nicely in your source code, and then in the target program, everything is wrongly indented and maybe invalid. And since the source languages that are user-friendly tend to be white space sensitive, that's clearly a big danger. And as I said, you don't really have modular unit testing for your code generation. So you just have what should test our input look like and test output look like, right? And then you slightly change indentation of your produced code, and you need to rewrite all your unit tests from scratch. So that's certainly not really feasible to use such fragile testing, right? So what we propose with Dmitry Krybov, with whom I worked on this project, is that we use the existing parsers that we already have on HaskellX and amend them, alter them, add the functionality to do two things, actually, not just code generation, but also code matching, so that we will be able to pattern match on the code to write robust unit tests and also code generation. Code generation will be using the existing parser plus template Haskell. How would it work? So this is a simple example of incomplete code. So basically, you can imagine that you have this template Haskell code that is here as a string inside. The important part is that you don't really need to care about indentation, or you can cut the indentation in front of the whole section, because when you start using template Haskell, you get a source location where your template starts, right? Where your quasi-quote, in this case, starts. So you use quasi-quote location to cut the initial indentation. Then the next thing you can do is to replace the select identifiers by variables. And use the Haskell HaskellX in this case, because it's Haskell for Haskell, but we are also interested in similar projects for PureScript and JavaScript. And you replace them by basically variables. You can generate both pattern match for this and the code generation fragment that is basically a data structure in Haskell HaskellX data that includes some variables. So that would be a fragment of Haskell code. And here I show how much better you can write the unit tests. So what you can do is, for example, write a condition that for all the tests of certain form, the top levels should have just one variable, right? Just one variable. We don't really care about the type because it may be generated. So you just know that in all these tests, there will be just one variable in the top type. This kind of input-output correlation is not done, to my knowledge, in other in unit testing of code generators. Another example, here you have concrete names, right? So you can also verify that. But this is simple input-output matching. That's the difference. So here This would be, any V would be basically a variable identifier or field name identifier. Any T would be type variable identifier. And C would be constructor identifier. Now, the next step in this project is to replace this by friendly syntax that we've seen just before a moment that indicates that this is actually escape and the variable, right? So this is half completed project, but we already have it working on small test examples. I think we will move JSON autotype and XML type lift to this new solution because it's much easier and much more modular to unit test code generator in this way. And since it's just 5 minutes, I'm ready for your questions and suggestions. Maybe you have an even better solution with regards to at least code generation on a shoestring, right? For many languages.
You said that you're using HaskellX. I didn't understand where that fits in because your example there is just a plain text.
You see, it looks like it is, but it's not your father's text or mother's text. This is not text. This is parsed by Haskell HaskellX. So if you want to switch to code generation or matching PureScript code, then you can use PureScript parser, right, for this. And then you check the syntactic validity here, right? At least syntactic validity is checked. Next step would be probably adding types to it, right? But syntactic validity is already going a long way, right? Because you check the syntactic validity of the template. Does it answer your question?
Yeah. Any other questions for Michał? If not, let's thank him again for a good lightning talk, and I think that's the end of the session.